everyone. I hope you all will be fine, safe and healthy at your home, and I hope you all will be enjoying your online classes. So let us start our today's session without wasting our time. The topic which I have brought in the today's session, that is of measurement of delta U and delta H. As you all know that I have taught in the previous session, delta U, this is the internal energy change, and delta H, this is the enthalpy change. Okay, so here you have to understand what is the calorimetry. Calorimeter we use. So the statement, you see what I have written, the heat changes associated with the chemical reaction is whatever the heat change during any chemical reaction can be measured by experimental technique, and this experimental technique is called calorimetry. Okay, so the measurement are made under two different conditions. The first condition, it is to be at constant volume, this is QV or delta U, and the second condition, this is at constant pressure, that we call it QP or delta H. This already I have taught you in the previous sessions. Okay, so let us understand about what is bomb calorimeter, which is helpful for the measurement of delta U and the delta H. So you can see here I have taken a big container. This is a big container. The construction I am just going to explain, see it properly. I have taken a big container, and this container must be insulated. Insulated means that you have to understand that is not able to supply the heat outside of the system. Okay, whatever the heat produced, that remain inside the system. So outer covering, this is of the insulated. So here I have written, you can see insulated outlet vessel. And after that we have to put a small vessel inside it. In the big container we have to put a small vessel. This is made up of steel, and this vessel, this we have to call it, this is a bomb. I have written here, this is a bomb. Okay, now after that we have to use here two electrodes, and with the help of these electrodes we will pass the electric current, and after that we have to fill the water around the bomb, means steel container. Okay, at one side we have to put the thermometer for the measurement of temperature, and at one side we have to put the stirrer, and a stirrer that will continuously move on, okay, moving, and that will circulate the heat and completely distributed the heat produced in the system. So now after that what will happen in the working, we have to take here the platinum cup, as I have written, you can see the substance in a platinum cup. So we have to put a specific chemical whose delta U and delta H we have to calculate. Okay, so now we have to pass the electric current from these two electrodes. As they will pass the electric current, the substance which we have kept in the platinum cup, that will start to heat up. So whatever the heat will produce, that steel container, that will accept this heat, and this heat will transfer in the water, and water will start to heat up. Okay, and whatever the temperature of water will rise, that will be measured with the help of this thermometer. Okay, so this is the construction and working of the bomb calorimeter. Now you see what formula we use for calculating the delta U. Delta U, it is to be calculated by using minus Z into delta T into M upon W. So delta T, this is the temperature change that we are observing with the help of thermometer. Okay, now you see here what are the specific terms. Z, this is the heat capacity of calorimeter system. Delta T, this is the rise in temperature, and capital M, this is the molecular mass of the substance, and W, this is the mass of substance taken. Like suppose you have taken 20 gram or 2 gram substance, so this will be of W, and if that accurate molar mass you are calculating, so this will be of M. So all these values we have to put in this formula. This will helpful to calculate the value of internal energy change. After knowing the value of internal energy change, for calculating the enthalpy change, we use the formula delta H is equals to del U plus del Ng RT. Del U we have calculated from the previous formula, that you can put here, and this will help to calculate the enthalpy change. So this was the construction and working of bomb calorimeter. So here I am reminding to you, this bomb calorimeter is specifically used to calculate or for the measurement of internal energy change or the enthalpy change. This you have to understand. And here bomb is what? This is the steel container, and the chemical substance is to be kept in the platinum cup because the reactivity of platinum is least, and the outermost container, this must be of insulated. Okay, so this is the main point about the bomb calorimeter, which we should know it properly. Okay, I hope you all have got it, what is the construction and working of bomb calorimeter properly. That's all for today's session.